Okay, so here we go on the back. We're going to start with these multiple choice problems, which are very similar to problems that you might see on the AP exam. The first question here is it's telling us the position of a particle moving along a horizontal line is s equals t to the third minus t 6t squared plus 12t minus 8. This might be a little confusing for some of you. That s is basically s of t. It's the function that tells me the position. And in number 18, I need to find when is the object moving to the right. Okay, so the right is basically when the velocity is positive, also known as greater than 0. If I want to know when it's greater than 0, I first need to find when is the velocity equal to 0. Okay, so I'm given the position function. To get the velocity function, I need to take the derivative of the position function. Okay, so we're going to take the derivative of that, and we're going to get the velocity function is 3t squared minus 12t plus 12. All right, and then we're going to say, well, when is the velocity 0, right? If I want to know when it's positive, first I need to know when is the velocity 0. So we're going to set that equal to 0. And then we're going to try to solve this. Okay, the first thing I'm going to do is notice how there's a common factor of 3 everywhere. I'm just going to divide everything by 3. Because it's 0 over there, I can do this and it's not going to cause any issues. It's just going to make my factoring life easier. And we're going to get that. And we can see that this factors into t minus 2 times t minus 2. So it's simply when t equals 2, right? This is when the velocity is 0. We're not done, right? We should not choose B because, I mean, that's not a good choice anyway, but it's saying at 2, the velocity is 0, right? So what I really need to do is determine, well, what happens left of 2, right? If I'm left of 2, what happens? So if I plug in a number 2, I can just plug it in here. If I plug in a number left of 2, I'm going to get, you know, like 1. 1 minus 2, this is a negative number. And then if I plug in 1 here, I also get a negative number, and I'll have a negative times a negative, which is a positive, right? So left of 2, my velocity is positive. So I'd check a number right of 2, like 3. If I plug in 3 here, it's going to be 3 minus 2, which is positive. 3 minus 2 is positive. I also get a positive over here because I multiply 2 positive, I get a positive. So my velocity is always positive except for at one single t value when it's 0, right? Because 0 is not positive, it's not negative. So the correct answer here is B, right? All values except for t equals 2, because at 2 it's 0. Okay, for number 19, it's asking for the minimum speed. We haven't really learned how to minimize functions yet, so I'm going to encourage you to use your calculator on this one. We want to minimize the speed. Remember, speed is the absolute value of the velocity, right? So let's go ahead and just graph our velocity up here, right? We had 3x squared minus 12x plus 12. We're going to go ahead and graph that on our graphing calculator, and we're going to see this. We want to know what's the minimum value of the speed. Speed is always positive. Remember, we're looking at the velocities here, right? This graph over here is the velocity. If you think about, and the speed is absolute value of velocity. So if you look at all these y values are my speeds, right? So this would be like a speed of 6, speed of 5, speed of 4, speed of 3, speed of 2, speed of 1, speed of 0. Well, where's the minimum speed? What's the smallest speed? What's the smallest velocity I see on here? And well, the answer is that it's at time equals 2, but the speed is 0. The minimum speed I see is 0 when it's stopped, right? Question 20 is, when is the acceleration positive? Remember, the acceleration is the derivative of the velocity. So I have my velocity function up there. The acceleration function is going just to be 6t minus 12, right? The derivative of the velocity gives me this. I want to know when it's positive. So again, first I need to find out where it's 0, which is, this is going to give us t equals 2 again. And then I'm going to put this on a number line just like I did before. I'm going to try some points over here, and I'm going to try some points over here to see where is it positive, where it's negative. All right, so that's how that's going to go. And then when is the speed of the particle decreasing? Okay, it's going to be decreasing when the velocity and acceleration have different signs, right? Because this is where, like they're opposite signs. This is where the acceleration is going to be pushing against the velocity, slowing it down, or in some cases, yeah, slowing it down, right? So it's going to make the speed slower. So what I would suggest is basically just create a table of values. There's only two things on here. It's from 0 to 2, and then from 2 to infinity on, right? These are my t values. And then you could have your velocity and your acceleration, and you can just fill this in with the values that you get. You know, like when is this, like I haven't done the acceleration, but you'd be like, oh, well, from 0 to 2, the velocity is positive. I know the velocity is positive here, and then I'd fill these in, and if the signs are opposite, then it's slowing down. If the signs are the same, then it's speeding up. All right, so that's that. Let's go ahead and look at the next one, see if we need any help on these guys. Oh yeah, there's one thing I want to say with this. Remember, we're trying to find when the particle is at rest. That's going to be when the velocity equals 0. So first I need to find the velocity, which is going to be the derivative of the position, which is going to be that. And I want to know, well, when is that equal to 0? Because at rest is a 0 velocity. And then I need to solve this. Again, why don't we factor out anything we can? So there's a 2t common in all of these. And then I get 2t squared minus 9t plus 12. And then I would try to factor this guy. And when you try to factor that, you should struggle because it turns out that it's not factorable. I can show you that here. If I actually graph that function, 2t squared minus 9t plus 12, you'll notice that there are no x-intercepts, right? It never crosses the x-axis, which is what we're finding here. So this part gives us no solutions, but this part gives me a solution, right? When does that piece equal 0? Well, that equals 0 when t equals 0. So the only place where it's at rest is when t equals 0, right? So answer choice there is B. When we look at 23, it's when is the velocity increasing? We need to look at the signs again, right? We need to figure out when is the, if the velocity is increasing, then we need to find out when is the acceleration positive and the velocity positive, right? The negative ones don't count because in that case, it would be decreasing because it'd be getting more negative. It's not talking about speed. 24, we just need to know when are the signs the same, right? When is the acceleration positive and the velocity positive, or when is the acceleration negative and the velocity negative. 25 is a little bit, it's definitely going to be hard. Displacement, we didn't really talk about, so I guess if you're watching this video, then you can skip 25. And then 26 is when does it reverse direction? How many times does it reverse direction? Well, in order to reverse direction, the velocity needs to equal 0, right? And it has to change from like positive to negative. So basically, you're just taking the derivative of this, setting it equal to 0, finding all the places where it equals 0, right? So let's just pretend it equals 0 there and there. And then we're checking a number over here and be like, oh, it was positive there and negative there, and maybe it was negative there again. In which case it only switched directions once at A, right? Because it stayed negative between B, so you wouldn't call that one, right? That's just an example of what you're trying to do to help you get started on that. So keep going. This one's also changing directions, right? Take the derivative, set it equal to 0. Please recognize that this will take a quotient rule, right? It's a quotient. You need to use quotient rule to find the derivative. Again, when does it change direction? You need to find out, well, when is the velocity equal to 0, right? And then whatever points you get, let's say it's here, you need to check numbers left and right of it to see if it's positive or negative and that kind of thing. So that's the process there. Moving forward, find the distance that the particle travels from 2 to 5. Distance is a bit tricky. Because we're given the position, right, which is not the distance. Let's just graph this so you can see what it looks like, right? 3x squared plus 2x plus 4 for t greater than 0. And we want to know what's the distance from 2 to 5. So let's look at something real quick, right? Let's look at our graph. Let's change our window. We don't need to see all the way over there, so let's make that 0, 0 to maybe like 7. And y, again, we don't need to go that low. Let's change this to like 20 and graph that. So here's my graph. Go ahead and just screen clip this so I can draw on it. All right, that's not working. So anyway, from 2 to 5, so I want to know, well, what's the distance from 2 to 5? I just basically need to find the change in position from 2 to 5 in that case, because it never changes, right? So I'm simply finding x of 5 minus x of 2, and that will tell me the distance. This would be different if I had gone like down at any point, because then you would have to add all these negative direction ones, right? This one, the position function of a particle is this. Find the velocity and acceleration. So basically just trying to find x prime of t and x double prime of t. Please look at this and see if there's some way you can simplify this beforehand to make your life easy. That would help you a lot if you could do that. And then we get down to this bottom one. And this one you should have changed right before. I don't think it said this before. This is what you make sure you change this one. I'm given the position function. I want to find the interval where the particle is speeding up and when it's slowing down. Let's go ahead and go through this one. Okay, so let's find the velocity first. The velocity is going to be 6t squared minus 12t plus 12. We first need to find out where the velocity is 0 and recognize that I can take out a 12 from all of these. And then, you know, I could divide everything by 6, so that goes away, and then factor this guy. It's going to be t minus 1, t minus 1. So the only place where the velocity is 0 is at t equals 1. So I'm going to do a little graph over here. Here's 1. I need to check left and right, so let's plug in like a number over here. Let's try 0. If I plug in 0, I will get 0 minus 0 plus 12, which is positive. So here the velocity is positive. Right of 1, like 2 or something, I would also get positive numbers, right? If you plug it in down here, you're going to get positive, positive, and so this is also going to be positive. So basically my velocity is always positive. I need to find the acceleration to see, well, when is the acceleration the same? So the acceleration is the derivative of the velocity, which is this. Set that equal to 0, and you're going to get t equals 1 again, right? So now this was my velocity. Here's my acceleration. I'm also checking at 1. Left of 1, if I plug in a number left of 1, this is going to be negative. And then right of 1, this is going to be bigger than 12, which is going to make this positive. So left of 1, my acceleration is negative. Right of 1, after 1 second, my acceleration is positive. So the idea is, well, in which case is speeding up is when the velocity and the acceleration at the same time, right? So I'd say speeding up happened after 1, which is t greater than 1. And then when did it slow down? Slow down when the acceleration is the opposite sign as the velocity, and that happened when t was less than 1. Right, so that's another example of how that works. Let's just look at this last one, see if you need help. Oh, okay, so we're given a table of values. We want to estimate the acceleration at t equals 6, right? Notice the time values they give us, 0, 4, 8, and 10. We're trying to estimate what happens at t equals 6, which is right in between 4 and 8, right? I need to estimate the acceleration. So think about if I'm given these velocity functions, and I want to somehow find the acceleration. Remember, if I was given the function, I would take the derivative to get to the acceleration, but I don't have the function. All I have is a table of values. So think about to yourself, well, if I was given the position, how would I get to velocity, like an estimation? And that's what we did with the secant line, right? The secant line gives an average velocity, which is like an estimation. So if I want to estimate the acceleration, I can do that same process with these velocity values to find the average acceleration. So the average acceleration between, well, near 6, which is using these guys, is going to be v of 8 minus v of 4 over 8 minus 4, right? Notice it's the slope of a secant line for the velocity, and v of 8 is 10, v of 4 is 16 over 8 minus 4. This is going to give us negative 6 over 4, which is negative 3/2, right? So I could say, well, the average acceleration is negative 3/2. Again, the units look like this. The average acceleration is this, which is the only estimate I can provide for using this table of values. And you don't see that specific answer, but it's equivalent to negative 1.5 on there. Okay. I hope this is helpful. I know I went really fast and stuff, but I'll just try to go where you need to go, and hopefully it helps.